let's talk about inverse functions and inverse relations. Now let's look at this diagram right here. It shows a relation. And this relation is a function because each input has exactly one output. But the inverse of it, when I switch my domain and range, when I switch my input and output, the inverse is not a function because each element of the domain goes to two different range elements. So when I talk about a relation and its inverse, basically I'm going to be swapping domain and range. So the domain of the relation becomes the range of the inverse, and the range of the relation becomes the domain of the inverse. And we can see one can be a function while the other is not. So we're going to talk about this inverse concept, and we're going to use this -1 here to indicate that we're talking about an inverse function. And you need to be very careful. This is not 1 over. This means inverse in this class. Now let's look at the definition. When I ask you to show that two functions are inverses, they're inverses if and only if, so this is a biconditional, f inverse composed with f evaluated at x is equal to x, and f composed with f inverse of x is equal to x. Then, and only then, are these two functions considered inverses. Now, remember, the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. So when exactly does this occur? Well, it occurs consistently only when we have one-to-one functions. A one-to-one function is a function who, for every element in the domain, there is exactly one range element. When that happens, then you can do the switch back and forth between the function and the inverse, and it actually goes quite smoothly. The domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse.